So still on inequalities. So this time we are to deal with rational inequalities. So for example, we have x minus 2 all over x minus 4 is greater than or equal to 0. So we are looking for the values of the left side to be greater than 0. So what are the values greater than 0? So obviously we have positive values or positive numbers are greater than 0. So when do we have a positive quotient? That is a positive divided by a positive is obviously positive. Then we have a negative divided by a negative is also equal to a positive quotient. We are avoiding the case of having negative divided by positive or vice versa, positive divided by a negative, since this will have a quotient. This will have a negative quotient. So since we are looking for values that are greater than or equal to 0, we are looking for positive quotients. So just to have our reference points, we have, I set this one to 0, x minus equal to 0. So one of our reference is x equal to 2. Then we have x minus 4 is equal to 0. This is x equal to 4. But for this case, we can't have x is equal to 4. Okay, for a reason, just in case, for example, if x is equal to 4, we'll be having a 0 denominator that will give us an undefined quotient. Okay, so on our number line, so our reference points we have, that is at x is equal to 2 and at x is equal to 4. So we have, we will be having again similar to the quadratic equation, quadratic inequalities. We'll be having 3 intervals for this time. So our first interval is from the negative infinity to positive 2. The second interval is from positive 2 to positive 4. Then the third interval is from positive 4 up to positive infinity. So let's say we have, let x is equal to, we are to consider a value between negative infinity to positive 2. We may consider, we may use 0, since 0 is between negative infinity to positive 2. If x is equal to 0, from this quotient, we have that as 0 minus 2 divided by 0 minus 4. So this will give us a quotient of negative 2 over negative 4, that is a positive quotient. So this interval will give positive values, or positive quotient. Then we have the next interval, that is between 2 and 4. So let's say, let x is equal to, we'll be using 3. So it's the same as 3 minus 2 divided by 3 minus 4. So 3 minus 2 is positive 1, 3 minus 4 is negative 1. This will give a negative quotient. So this interval will give negative quotient. And our last interval, let's say we are using 5. So let's say that x is equal to 5. So this is the same as 5 minus 2 divided by 5 minus 4. So 5 minus 2 is positive 3, 5 minus 4 is positive 1. That will give us a positive quotient. So this is also positive. Take note that we are looking for positive quotients since we have the sign greater than or equal to 0. So for the solution set, a solution set is what intervals gives a positive quotient, that is from negative infinity to positive 2. So using inequality, this is from negative infinity, or let's say x is less than, 2 is included, less than or equal to 2. Or, take note again, 4 is not included since we'll be having a 0 denominator that will give us an undefined quotient. So we have, that is from negative infinity to positive 2, that is the same as x is less than or equal to 2, or we have 4 is, we have x is greater than 4. For a reason, positive 4 is not part of the solution. So this is our solution set in terms of inequality. So by interval notation, that is from negative infinity to positive 2, then union, so again, 4 is not included, that is from positive 4 up to the positive infinity. And then we have, how do we present the solution set using the number sign and the number line? This is 2 is included, so this is a closed circle, then an arrow towards the negative infinity. Then 4 is not included, so that will be an open circle towards the positive infinity. So this is our solution set. Okay, so let's have this example. X plus 3 all over x minus 2 is less than 2. To start the analysis, I think it's more simple if we are to let one side of the inequality to be 0. So we have this as x plus 3 divided by x minus 2. This is minus 2 is less than 2 minus 2. To have as x plus 3 divided by x minus 2 is less than 0. Then we have a common denominator here. This is x minus 2, x plus 3 minus twice of x minus 2, so less than 0. So we have this as x minus 2x is negative x plus 3 minus 2 times negative 2. So it's the same as 3 plus 4. We have 7 divided by x minus 2, or this is less than 0. So this is the simplified form of the given. We have this is a negative x plus 7 divided by x minus 2 is less than 0. So what are the values that are less than 0? Obviously, negative values or negative numbers are less than 0. So this time, we are looking for a quotient that will give us a negative quotient. So a ratio, or yes, a ratio that will give us a negative quotient. So this is, when do we have a negative quotient? It is negative divided by positive, or positive divided by negative. So that will give us a negative quotient. So this time we are avoiding the case of positive divided by positive, or the negative divided by negative. So this time, we are looking for a negative quotient. So just to have our reference points, we have, this is a negative x plus 7. We set this to 0. So we have x is equal to positive 7, one reference point. Then we have x minus 2 is equal to 0, x is equal to 2. But again, we are using x is equal to 2 as our reference, but we can have x is equal to 2. For a reason again, 2 minus 2 will be a 0 denominator that will give us an undefined quotient. So on our number line, in our number line, we have our reference values. We have 2 and 7. Okay, so let's x is equal to, let us consider again 3 intervals. So first interval is from negative infinity to positive 2, then positive 2 to positive 7, then positive 7 to the positive infinity. On our first interval, let's say I can use x is equal to 0. So this is negative 0 plus 7 divided by 0 minus 2 is equal to, we have that as 7 divided by negative 2. This is a negative quotient. And then we have, let x is equal to any value between 2 to 7 for the next interval. So let's say we are using positive 3. So this is from negative 3. Negative 3 plus 7, this is divided by 3 minus 2. So negative 3 plus 7 is positive 4. Negative 3 plus 7 is positive 4. 3 minus 2 is positive 1. That will give a positive quotient. And lastly, we have let x by any value from the third interval from 7 to the positive infinity. So let's say x is equal to positive 8. So this is the same as negative 8 plus 7 divided by, this is 8 minus 2. So negative 8 plus 7 is negative 1 divided by 8 minus 2 is 6. So negative 1 over 6 is negative quotient. So if you have to review, if on the first interval, it will give negative quotient. Second interval from 2 to 7, it will give positive quotient. And lastly, we have on the third interval from 7 to infinity, that is also negative. So again, we are looking for values that are less than 0 or that is a negative value or negative quotient on the left side. So for the solution set, so in terms of inequality, which intervals satisfy the inequality? We have negative, negative. This is x is less than. Take note since we have less than sign. X is less than positive 2 or that is x is greater than 7. That is our solution set in terms of inequality. Our solution set in terms of the interval notation, this is from negative infinity to positive 2 union, we have 7 up to the positive infinity. So we are using parentheses since 2 and 7 are not included or not part of the solution. Or actually, we may include positive. We cannot include positive 2, and since the symbol is just less than. And lastly, on our number line, that is, so again, positive 2 is not included. So this is an open circle. This is towards the negative infinity, and positive 7 is also not included. This is towards the positive infinity. We are using open circles. So this is our, these are the solution set for this rational inequality. Let's have this case, that is the inequalities with absolute values. For example, we have the absolute value of x plus 2 is greater than 4. So we are to consider the two possible cases. That is, what if we have x plus 2 is actually greater than 4. If we are just to remove the absolute value sign, what if x plus 2 will satisfy the inequality? That is, its value is greater than 4. So let's have that as x plus 2 minus 2 is greater than 4 minus 2. So we have the first inequality solution set, that is x is greater than 2. That is the first possibility. The other possibility or the other case, that is, what if this value is actually negative? Then you have to use absolute value just to make it greater than 4. So let's have it as the second possible case. What if this value is negative? The quantity x plus 2 is greater than 4. So it only satisfies the case greater than 4 if you are to use the absolute value. So dividing both sides of the inequality by negative 1, this is now x plus 2. Since we are to divide both sides of the inequality by a negative number, we are to change the sense of inequality. This is now less than negative 4. So we'll be having x plus 2, this is minus 2, is less than negative 4 minus 2. We have the other solution set, x is now less than negative 6. So these are our solution sets. So we have at x is greater than 2 and at x is less than negative 6. On our number line, so So in our number line, how do we present the solution set? We have x is less than negative 6. This is towards the negative infinity. And negative 6 is not included, so we are writing an open circle. Then we have x is greater than 2. Okay, greater than, this is towards the positive infinity. And again, we are using open circle since 2 is not included in our solution. So that is by a number line. Then by interval notation, this is from negative infinity up to negative 6, since union from positive 2 up to positive infinity. So this will be our solution set. So let us try to check if our solution sets are correct. So let's say we are using a value we are using a value from negative infinity to negative 6. Let's say let x is equal to negative 7. Is the absolute value of negative 7 plus 2 greater than 4? So obviously this is correct. Since negative 7 plus 2 is negative 5, absolute value of negative 5 is positive 5, which is greater than 4. So for example, what about on this interval? Let's say we are using x is positive 3. The absolute value of positive 3 plus 2 is greater than 4. Yes, that is also correct. So what about if we are to use any value between negative 6 and 2? For example, 0. That is 0 plus 2 is 2. Absolute value of 2 is not greater than 4. So this is our solution set. So for this example, we have the inequality with absolute values. That is 5 over 3 multiplied by the absolute value of 2x plus 2 is less than 10. So simplify first. And let's have all the terms with the absolute value on one side of the inequality. So we are to multiply both sides of the inequality by the 3 over 5. So this is the same as 2x plus 2, or the absolute value of 2x plus 2 is less than. So 10 over 5 is 2 times 3, we have the rest 6. Then again, we are to rewrite our inequality considering the two cases. So what if this value is actually less than 6? We have that as 2x plus 2 is less than 6. So we have 2x plus 2 or minus 2 is less than 6 minus 2. We have this as 2x is less than 4. Dividing both sides by positive 2, so we maintain the sense of inequality. We have the value of x is less than positive 2. So this will be our first solution set. So the other case is that what if this value is actually negative? That makes it less than 6. So this is negative 2x plus 2 is less than 6. So dividing both sides of the inequality by negative 1, this is now 2x plus 2 is now, since we are to divide both sides by negative 1, we are to change the sense of inequality is greater than negative 6. So we have this is as 2x plus 2 minus 2 is greater than negative 6 minus 2. So we have 2x is greater than negative 8. Dividing both sides by positive 2, we have x is greater than negative 4. So let us observe this two references on our number line. As you can see, we have on the first, x is less than 2, which means that is towards the negative infinity. And we have here, x is greater than negative 4. So which means this should be towards the positive infinity. So what will be our solution set? So they have an intersection. They are pointing on opposite direction towards the negative infinity and the positive infinity. So let us observe every intervals. So what are the intervals that are we going to consider? First interval is from negative infinity to negative 4. Negative 4 to positive 2, the second interval, and last interval from positive 2 to infinity. So let's, for example, okay, I'll be using negative 5. So let x is equal to negative 5. So will it satisfy the inequality? So this is 5 over 3 multiplied by the absolute value twice of negative 5. Okay, plus 2 is less than 10. So 2 times negative 5 is negative 10 plus 2 is negative 8 times 5. Absolute value of negative 8 is positive 8 times 5. That is 40 over 3. Is it less than, so we place a question mark, is it less than 10? Is 40 over 3 less than 10? That is 40 over 13.33 is not less than 10. So this is not 2. Okay, so it does not satisfy. This interval does not satisfy the inequality. So we have here, okay, so we place it as, we place a wrong mark. It doesn't satisfy the inequality. Next interval, what about a value between negative 4 and positive 2? Let's say, let x is equal to 0. We have 5 over 3, absolute value of 2 times 0 plus 2. Is it less than 10? So 2 times 0 is 0. So absolute value of 2 is positive 2 times 5 is 10. This is 10 over 3. Is it less than 10? Okay, so obviously this is correct. 10 over 3 is less than 10. So this interval satisfies the inequality. Then we are considering the last interval from positive 2 to the infinity. So this is, let x is equal to positive 3. So we have 5 over 3, the absolute value of 2 times 3 plus, plus 2, is it less than 10? So 2 times 3 is 6 plus 2 is 8. Absolute value of 8 is 8 times 5 is 40 over 3. Is it less than 10? So obviously it's not less than 10. 40 over 3 is not less than 10. So this is also an interval that cannot satisfy the inequality. So therefore, what will be our solution set? For our solution set in terms of inequality, that is from negative 4 to positive 2, that is negative 4. Okay, negative 4 is less than x, less than positive 2. In terms of interval notation, that is from negative 4 up to positive 2. So our number line, if we are to represent the solution on our number line, open circles, which means negative 4 and positive 2 are not included in the solution, from negative 4 to positive 2. So that will be our solution set for this inequality. So be careful if you are analyzing the solution set, or if you are solving for the solution set of inequalities with absolute value. So like this one, for example, we have the absolute value of x plus 1 is greater than negative 2. Alright, so when you observe, the absolute value of x plus 1 is greater than 2. Whatever is the value of x, and whatever is the value of x, it will satisfy this inequality. Why? For a reason, for example, we have a 0 plus 1 is greater than negative 2. Okay, that is correct. Negative 1 plus 1 is greater than negative 2. That is also correct. So any value of x will satisfy this inequality. Take note that if you are to use the absolute value, that will always give us a positive value. Or other than 0, which is always true, that is always greater than a negative value. So for this case, what will be our solution set? Any value of x may do, that is from negative infinity to positive infinity. So any value of x may do, so So this will be the solution set for this case. So absolute value or positive value is always greater than a negative value. So what if we do it another way around? What is the absolute value of x plus 1 is less than negative 2. So take note, if you are using an absolute value sign, the value or the other than 0, we will always have a positive value. And is a positive value less than a negative value? So obviously, no. Positive value will never be less than a negative value. So this is not true. So we may consider for this case that an absolute value or always be a positive value will never be less than a negative number. So we may consider or we may conclude that this is no solution.